This is an H-bridge transformer driver based on the quadratron isolator design. It's powered by power over Ethernet. And if I take the Ethernet cable out, the MOSFETs are no longer switched. The external battery packs are no longer powering the LEDs. Once I take the power out, then we can see the Arduino here on the top with the USB plug and the Ethernet with power over Ethernet shield below. And then I have my simple one-phase frequency generator program running on this Arduino, and I have these two boards, one on the top and one on the bottom, which are each builds of a single channel of the quadratron isolator schematic. And each of these single channels is driving two MOSFETs. So not MOSFETs, IGBTs. One IGBT can be on the top of the coil and the other IGBT on the bottom of the coil. I use these two potentiometers to change the duty cycle and the frequency of the driver. And these are the two independent channels. One on the left here. This goes to the top of the top MOSFET. This goes to the bottom of the top MOSFET. This goes to the top of the bottom MOSFET. And this goes to the bottom of the bottom MOSFET. So I can see that we have power coming in, and then the load, which would usually be a coil, and then power going out. And then the same thing here, so power coming in, load, and then power going out. Now, if I plug it in again, LEDs are being lit again, and you can see one of the channels current is being measured, about 9.5 milliamps. But we see on the scope, on the top is the voltage waveform, on the bottom is the current waveform, and it's in 10 milliamps per division. So we see that the current probe thinks that it's drawing slightly over 10 milliamps, but for only a fraction of the duty cycle. 6% duty cycle. So the next thing I'm going to do with this is drive the transformers of two plasma globe flybacks to make another recreation with this new, nicer arrangement of parts, so that I can drive the plasma globes tantratron style. Anyway, this is a really cool build. Fits nicely in this box, just barely managed to make it all fit. And it's really clean. The inputs and outputs for the two isolated channels and for the two MOSFETs per, or IGBTs per channel are easy to access with this terminal strip here, and the frequency and the duty cycle is easy to adjust. And because I'm driving it with power over Ethernet, driving the Arduino, powering it with power over Ethernet, I could conceivably change the program so that the frequency and duty cycle, instead of being powered by the potentiometer, are programmed using UDP packets or TCV packets or whatever. And that would be really cool.